In this video, I'll introduce the concepts for scripting using the Bash shell in Ubuntu Linux. In essence, scripting allows you to automate many common tasks that you would perform using the terminal in Linux. It is a very powerful skill for system administrators to learn. First, I'm going to create a bin folder inside of our home folder. This will become very useful later. In the command that I just used, remember that the tilde character here represents your home folder. It's one of the special paths that we can use on a terminal in Linux. Next, we can open that folder. To begin, let's open a text file using nano in the terminal. I'm going to use the .sh file extension on it to make it clear that it is a script, but that's not really necessary on Linux. At the very top of that file, we must define the script interpreter we would like to use. For Bash, you'll need to place this line at the top of every file. Some more experienced system administrators will refer to the start of that line as a shebang, which may make it easier to remember. It's actually a 2-byte magic number that tells Linux what type of file it is reading, and then the rest of the line gives the path to the program that can interpret that file. This allows Linux to determine the type of the file even without checking the file extension, which is what Windows does. Below that line, you can simply place terminal commands, one per line, that you wish to have the script perform. For example, here is a simple Hello World script. The echo command in this script is pretty self-explanatory. It just prints text out to the console. The final line here gives the exit condition for the script. Returning 0 indicates that the script completed successfully. Any non-zero value is treated as an error and can be used to diagnose failing scripts. If you're interested in learning more, see Chapter 6 from the Advanced Bash Scripting Guide from the Linux Documentation Project for more information on exit conditions. It is linked below this video. To save this script, you'll need to save and exit the file using nano. In nano, you press Ctrl X, then Y, then Enter to save and close a file. To run the script, we would simply type /script.sh, the name of the file. Notice here that we're using the dot or period in front of the slash. This is another one of those special directories in Linux. A single dot represents the current directory, and 2 dots represents the parent directory. By doing so, we're indicating to the system that we want to run the script with this name from the current directory and not anywhere else. At the end of this video, we'll discuss how to modify your system so you don't have to include that path in the script. Unfortunately, it doesn't run. This is because Linux has a separate file permission to allow files and scripts to be executed. By default, most files are not given that permission, so we have to manually add it before executing the script. To do so, we can use the chmod command. If you remember the lecture on Linux permissions, here we are adding +X, we are adding the execute permission to the user or owner assigned to the file. Now we can try and run the script again. This time it should work. Congratulations, you've written your first Bash script. Now let's take a look at a more complex script. This is one I actually wrote years ago when I first interviewed for an instructor position here at K-State. There's quite a bit of stuff going on in this script, so let's break it down piece by piece. At the very top, we still have our shebang with /bin/bash to note what type of file this is. Below that, I've included one comment prefaced by a hash sign to indicate the name of the file. That is totally optional, but you can include comments in your scripts just like you would on any other programming language. At the top, we have different parameters in this script. The $1 represents the first parameter, obviously $2 would be the second parameter, and so on. For parameters above 9, you'd have the number in curly braces with $curly brace 10, close curly brace, and so on. You can also access the number of parameters provided using the $hash special variable and the entire parameter string as a $sign followed by an asterisk. Now we have this first statement right here. This statement uses double parentheses, representing arithmetic evaluation. In this case, it's checking to see if the number of parameters is less than 1 or greater than 1. This is a shortcut for basically checking to see if the number of parameters is exactly 1. If it is not exactly 1, it will print an error message to the screen. Finally, it will then exit with a non-zero exit condition, indicating that the script encountered an error. Lastly, note that if statements are concluded with a backwards if or fee, indicating the end of the internal code block. In many other programming languages, curly braces are used for this purpose. The next if statement uses square brackets for a logical test comparison. This is equivalent to using the Linux test command on that statement. Here, the script is checking to see if the string value in the first parameter exactly matches the string value Batman. If so, it will print the appropriate welcome message. After that, we have an else if to check to see if the first parameter is Robin. Then, if so, it will also print the appropriate welcome message. If neither of those are the case, it will print the intruder alerts. This simple script introduces two different methods of comparison, as well as conditional statements and parameters. Let's save it and run it and see what it does. Remember that I have to give it permissions first. If I run it without a parameter provided, it will print that error message and exit. If I provide a parameter for Batman, it will print the correct message. Similarly, if I print Robin. Note that it is very case sensitive in this case, and so anything other than Batman or Robin will trigger the intruder alert message. Here's another simple script that introduces a few other concepts. The very first line of this script declares a new variable called files, and then it sets its value equal to the output of this command. Here I'm using backticks, which is the tilde key, to indicate that it should run this command and replace it with its output to be stored in that variable. This next line right here represents a for each loop. It will execute the code inside the loop one time for each line in the files variable. Note that when variables are declared and assigned initially, they do not have the $sign in front of them. But when they are used, we must include that $sign at the front. The loop is concluded with a done indicator. This is similar to a closing curly brace or the fee that we saw earlier from the if statement. Once again, let's save and close that file. Give it execute permissions. Now let's run that script. It expects one parameter as a file path, so I'm going to give it ~/. You'll note here that it just prints out all of the items in my home folder in order. In effect, this script is kind of a quick replacement for an ls script, but it actually uses ls inside of it anyway. Let's review another script. This script creates a simple menu with 4 options. Those options are stored here in this options variable, separated by a space. It then uses a select statement, telling the terminal to ask the user which of the options they would like to perform. Then, inside of that select statement, we use a set of if statements to determine which option the user chose. This is very similar to using a case statement in many other programming languages. When you run this script, you'll note that it repeats the options until it hits an option containing the break statement, which is the quit option right here. Therefore, it's not necessary to encapsulate this in a loop if you'd like it to continue over and over again. Let's go ahead and run this script as well. So you'll notice here it gives me a menu with the 4 options. If I press 1, it will do the build option. 2 will do the run option. 3 will do the clean option. And then if I choose 4, it will quit. Any other option will be deemed invalid. So this is a very simple way that you can create a menu for the scripts that you would like to run. Lastly, bash scripts also allow you the ability to read input from the user directly instead of using command line parameters. In this script, I use the read command to read input from the user and store it here in this name variable. Remember, once again, when you declare and assign variables, you don't need the $sign in front of it, but then when I use it later, I need to include the $sign. Pretty simple, right? So if I run this script, it will ask me for my name. I can type it in, and then it will print out my name. If you plan on writing scripts for your own use, there's one thing you can do to greatly simplify the process of using them. Notice that currently you must provide the full path to the script using either // or some other path. This is because, by default, Linux will look for commands and scripts in all of the folders contained in your path environment variable, but not the current folder. So we must simply add the folder containing all of our scripts to the path variable. In recent versions of Ubuntu, all you have to do is create a bin folder in your home folder as we did above. Then, when you restart the computer, it should automatically add that folder to your path. This is because of a setting hidden in your bash profile configuration file, usually stored in your home folder as .profile. The same process works for the Windows Subsystem for Linux version of Ubuntu as well. You can check the current path variable using this command. Echo followed by path as a variable. If you don't see your bin folder listed there after you've created it and rebooted your computer, as it shows right here, you may need to add it manually. To do this, you can open your bash settings file, /bashrc, and then at the very bottom of this file, we'll add another line. Here I've added a line to add the home folder /bin to our path. You'll notice that there's already a line up here for adding Puppet Labs to the path. If you'd like, you can combine these two lines together as well. That's just fine. To see this change, you'll save this file and then close and reopen your terminal. Now, if I look at my path variable, you'll notice that it includes the bin file twice. Seeing that change. Once you've done that, you can directly access any script you've created and stored in your bin folder without providing the full path. So, for example, that very first script we created, stored in script.sh, can now be accessed by simply typing script.sh. I don't need to be in the bin folder, and I don't need to give the full path to access that file. This is a very brief introduction to bash scripting. I highly recommend reading the Advanced Bash Scripting Guide from the Linux Documentation Project, or TLDP, if you'd like to learn even more about scripting. There are also several great books available online to teach you even more about how to build your own scripts.